So today we're going to discuss polygons, congruency, and polyhedrons. Okay, talking about that, we're going to start off firstly with triangles. So we need to understand triangles, and then when we understand triangles, we can move on to other polygons, and then we can move on to congruencies and polyhedrons. Okay, so triangles. When we talk about triangles, we are talking about a closed shape that consists of 3 angles and 3 sides. The sides of a triangle are all straight, but they vary in size. The angles of a triangle also vary in size, and that's how we have different shapes in a triangle and different names for each of those triangles. So, if I share my board with you, and we look at a triangle. Triangle A, B, C. Now, when we talk about this triangle, we can talk about angles AB, BC, or CA. Now, whichever way we choose to call it out doesn't really matter. Okay, we can say AB. We can also say BA. We don't have to specifically have an order. When we talk about angle A, we refer to it as that. That is one of the ways in which we can write angle A. Or alternatively, we write angle A. That also represents an angle. Okay, when we are referring to more than one angle, like we say angle A, B, C, okay, the middle letter, whatever is the middle alphabet, that will take on the angle symbol, okay? That is the one that we put the angle symbol on to. Okay, so like I said, it doesn't really matter in which order you write this down. You can write AB, you can write BA, you can write CAB, BAC. At the end of the day, you're still going to work out the angles, okay? So that's basically how we call out angles. A triangle can be classified in terms of aspects. When we talk about how do we classify a triangle, we can refer to things like sides and angles. Okay, so now we're going to talk a bit about classifying these triangles, the sides and the angles. Over the last couple weeks and probably the last couple of years, you guys have dealt with different types of triangles, okay? You've definitely worked with angles like a scalene triangle. What do we know about a scalene triangle? Okay, the thing we know firstly about the scalene triangle is all 3 sides are different lengths, okay? All 3 sides have different lengths. So a scalene triangle, all 3 sides are a different length. Okay, then we know about an isosceles triangle. And what do we know about an isosceles triangle? In this particular triangle, we know that the length of 2 sides are equal. So these will show that the length of 2 sides are equal. So if they did not tell you what type of triangle this was, and you just had a triangle with these 2 lines on it, you would automatically know this is an isosceles triangle because it is showing us that these 2 sides are equal. Okay, so we know scalene, all 3 sides are different. Isosceles, the length of 2 sides are equal. Okay, then we get an equilateral triangle. What do we know about an equilateral triangle? We know that the lengths of all 3 sides of the equilateral triangle are equal. Okay, the lengths of all 3 sides are equal. So very easy when you're working on a geometry paper to basically look at the shape. What is it showing us it has? If they have 3 different lengths on it, we know automatically it's a scalene triangle. If we have two sides equal, we know it's an isosceles triangle. And if we have all three equal, which is 60 degrees, 60 degrees, and 60 degrees, we know it's an equilateral triangle. And as we've spoken before, these triangles add up to 180 degrees all round. Okay, now when we talk about classifying triangles, I said there's two ways in which we do it, in terms of sides and in terms of angles. Now we've done the sides, now we're going to work in terms of angles. So the first thing we're going to start with is an acute triangle. Oops. Okay, in an acute triangle, all three angles of the acute triangle are less than 90 degrees. Okay, in an acute triangle, we know that all three angles are less than 90 degrees. Oops, oops, oops. Angles are less than . Okay, in an acute triangle, all three angles are less than 90 degrees. Then we have something called the 90-degree angle. What do we know about a 90-degree angle? Okay, a 90-degree angle is a triangle is a triangle that has a 90-degree angle in it, and we can identify that by the square that we see inside the triangle. So we know one angle of a right angle triangle is a 90-degree angle. Okay, so let's just quickly recap. An acute triangle, all angles are less than 90 degrees. A right angle triangle, we know that one angle of this triangle is a 90-degree angle. Okay, so let me turn over. So we have, oh, let me clear this place so we have some space. Okay, let's talk about an obtuse angle. What do we know about an obtuse angle? One angle of the triangle of an obtuse angle and two other angles are less than 90 degrees. So one angle is greater and two angles is less than. So one angle is greater than 90 degrees. One angle is greater than 90 degrees and two angles are, and the other two angles are acute angles, so they are less than 90 degrees. They are acute angles, which makes them less than 90 degrees. So they are less than 90 degrees. Okay, so quick recap, we did an acute angle. Okay, those angles are, all sides are less than 90 degrees. We did a right angle triangle. We know one angle of it is a is a 90-degree angle. And then we've got the obtuse angle triangle, which is we have one side that is greater than 90 degrees and we have two sides that are acute angles, which means they are less than 90 degrees. Okay, so now I'm going to share my screen with you before we do a recap. Okay, so let's look at this worksheet together. Okay, it asks us to describe each of these triangles below in a couple of ways, or two ways. So let's look at the first triangle. Automatically, we know this is an isosceles triangle. Okay, so we know this is an isosceles triangle, and what do we know about an isosceles triangle? Two sides of equal length, and the opposite angles are equal angles too. So two of the angles are of equal length. So that's what we know about an isosceles triangle. Moving along, this is a right angled triangle. And how do we know it's a right angled triangle? Because we can see here in the little corner, there's a right, and one angle has a 90-degree angle on it. Coming down to C, if we look at this, we can see there's no obvious signs that it's an equilateral triangle. There's no obvious signs that it's an isosceles triangle. It is a scalene triangle. Okay, so when we work with a scalene triangle, what are we talking about? We know all three sides have different angles. Okay, they have different lengths and different angles. So scalene triangle, different lengths, okay, and different angles. Moving along to D, what does D look like to us? D looks like an equilateral triangle. Does it look like an equilateral? No, it's also a scalene. We can see there's three different sides to it. Okay, so once again, C and D are similar. We know that they have three sides of different lengths and all three angles are different. Moving along to E. Once again, this is a 90-degree angle. We know that it's a right angled triangle and it has 190 degrees. And finally, F. F is an equilateral triangle because it shows us that all three sides of the length are equal and they have three equal angles. Okay, so I'm going to take you down to the bottom of this page, and it said, look at these triangles and answer these questions. A says, how many lines of symmetry has an equilateral triangle? Now, let's look at this equilateral triangle. How many lines of symmetry does an equilateral triangle have? It has three sides. Okay, an equilateral triangle has three sides. What is the order of rotational symmetry of an equilateral triangle? It is 3. So if I can actually show you, I'm just going to stop sharing this quickly and use my board. So when I say that an equilateral triangle, the rotational symmetry is 3, what I'm basically saying, so if I do 3, so I'm going to go 1, 2, 3, then I'm going to go 1, 3, sorry, 2, 3, 1, then I'm going to go 1, 2, 3, and then I'm going to go 1, 3, 2. Okay. Okay, so you can see how it can rotate 3 times and come back to where we started. Okay, so let's go back to the worksheet we were on. Okay, so the next one says, how many lines of symmetry has an isosceles triangle? Now let's look at this isosceles triangle that's in front of us. How many lines of symmetry does it have? It has 1, okay, 1 that goes straight down the middle. Okay, and then it says, what is the order of rotational symmetry of an isosceles triangle? How many times can an isosceles triangle, what's the order of its rotational symmetry, should I say? And it is 1, okay? It is only 1. E says, how many lines of symmetry has a scalene triangle? Now, let's look at the scalene triangle, guys. Does the scalene triangle look like it could have more than 1, or can it even have a line of symmetry? And the answer is no, okay? Scalene triangle does not have a line of symmetry because it's all 3 different lengths and 3 different angles. So we cannot get a line of symmetry here. So the answer for E will be 0. F says, what is the order of rotational symmetry of a scalene triangle? Well, Guys, if we cannot have a line of symmetry, there's no way we can have an order of rotational symmetry in a scalene triangle. So once again, it is 0. So there's 0 line of symmetry and 0 order of rotational symmetry. Okay. Are you guys better grasping this? You can identify the different triangles and look at it and say why each one stands out from each other and what makes them different. Okay, so we're going to do a quick recap. We're going to do a quick recap of the triangles that we just worked with. Okay, we said a triangle is a closed shape that consists of 3 sides and 3 angles. And we said the sides of a triangle are all straight, but the sizes are different. Also, all the angle lengths are, they vary, so they all are not the same. Okay, we said we can say angle A, angle B, angle C, and we can write them in whichever order we want to. They will still come up to the same calculation, and I've showed you how to work out how to write angle. Instead of writing the whole word angle out, the short for it, okay? Then we also worked with the different, we said a triangle can be distinguished or identified by 2 ways. So we classify it in aspects of angles, and we classify it in aspects of sides. And we spoke about the sides, and we worked with the right angles. We worked with isosceles, we worked with scalene, and we worked with the right angle triangle. And we said that a scalene triangle, as all 3 sides are different, and they are less than 90 degrees, and that's a cute, sorry, less than 90 degrees. And we said the isosceles triangle, 2 sides are of equal length. Yes, guys, if you are confused, the line of symmetry and the rotation, if it is 3 lines of symmetry, it will be able to rotate 3 times. If we have 0 lines of symmetry, it will not be able to, there'll be none. Okay, 1 line of symmetry and you'll be able to rotate once. Okay, so is there any questions concerning what we have just done? Can I keep recapping then, guys? Okay, we said in a scalene triangle, all the lengths of the 3 sides of the triangle are all different. We said in an isosceles triangle, the length of the 2 sides of the triangle are equal. And then we spoke about the equilateral triangle, and we said in an equilateral triangle, all 3 sides of the triangle are same or are equal. Okay, they're all 60 degrees. And I showed you pointers to use to identify things to look for when you're looking at a triangle, to be able to identify what type of angle it is. And you can identify this by the sides, or you could identify it by the angles.